Hello and welcome to Networks, and we're going to look at routers today. So my aim is basically, until we can go through some A-level computer science stuff, I thought I would teach networks in a little bit more detail, okay, than before, so you've got a better understanding and a better grasp of how things work. So now we're going to understand what a router does and how it works. Now I would have went through this with you in year 10, okay, but probably briefly in comparison to how I'm going to discuss it with you today. So you're going to describe the purpose of a router, you're going to describe how routers store computer addresses, and understand how data packets are transmitted. Right, so that's the success criteria. Now, what are routers? So we see these things in our home, okay, so they're somewhere in your home, somewhere around, but do you really think about how they work? Okay, do you really think about how you're receiving the signals and exactly what they do? Now, the one that I've seen most commonly in homes here, for example, is the Movistar one right here. So most people here are on Movistar. So now, basically, all it is a piece of hardware. Okay, so now obviously hardware is something that you can touch and you can use. So a router really is no more than a box that has circuit boards in it, wires, that kind of thing, okay? But what they do is they're designed to receive, analyze, and move incoming packets of data to another network, okay, and around networks. So incoming packets of data could be anything, such as emails, messages, videos, whatever you do on your computer, okay? Everything you do is data, okay? So the router will accept the incoming packets of data arriving, connecting to a local area network. So a local area network could be, for example, well, you have a local area network at home, okay? Because, you know, your phone, your computer, your games console will all be connected to this router, okay? A local area network, for example, could be in school. So then it will read the destination of the address embedded in each packet and work out which other land it is connected to and the best one for that particular data packet. So you're probably thinking, what are you talking about? Well, this is going to get a bit more clearer, okay? So what are data packets? Now, all they are is basically, this is data sent over the internet and broken down into small parts. So let's take an example here, okay? You have your phone. Your phone is connected to your router. You've just taken a selfie and you want to send that selfie to your friend, okay, using WhatsApp. Well, that selfie, that picture is a data packet, but it's broken down into loads of different packets, okay? So it can actually be transmitted quicker, because if it was transmitted as one whole image, it's going to take longer to get there, okay? So the router will send it to the best possible route to the endpoint, okay? So this is all sent wirelessly. Now, if it was done through wires, it'd be going through one wire and go to another wire and to another wire, but it's obviously done through radio waves. And then each packet is reassembled together at the end, okay? So the router basically provides a link between these two networks. So sending the data packet from your phone, your picture, to your friend's phone is basically two networks. So your router is, obviously your phone's connected to your router, and then your friend's phone is connected to their router. So that's going from your network to their network. So what they'll do is they'll work together to direct the data packets to their correct endpoint, which will be your friend's phone. So they can provide this link intelligently and efficiently because the router will make a decision about whether the message should be passed between the networks, and if the format is suitable, okay, because I understand that you may have sent something before, maybe it can't send it, to interpret it and accept it, and read the information and make sure it's sent to the destination for the best possible route. Okay, and provide a network connection between two networks. So how do they store the addresses? Well, routers are intelligent, so it does it as it's named, it routes something. Okay, so it decides the route the data packet should take, but it needs a list of addresses. Okay, and this is known as a routing table, and the data files basically could be stored in a RAM. Now, the table on each router has an address of the next router, and the main purpose of this is to forward the data packets to the different destination addresses. So this means it will decide on a particular route. So here's an example, okay? So this is the data packets that could be sent, like I gave you an example of, you know, a photo. So it could be, for example, if you type in a web address, send an email, or maybe watch a video on YouTube, okay? So what it does is it will have the packet's ID number, its position, and the sender's address. So this is an example that's in the book, okay? So your selfie will have packet ID details, such as going to Carlos's phone, I don't know, maybe. The source address, which is probably your phone, okay? So packet ID details, like I said, could be my selfie. Then the source address is your phone, okay? Then the destination address is Carlos's phone. And then the data inside it would be your selfie. Or we could think of it like this, okay? So here's an envelope, and in the envelope has got your picture in it, okay? So your selfie that you've taken, probably with, you know, the mask you're wearing because you're about to go out, because today, you know, you're all allowed out, and, you know, 2 fingers sticking up like that, say peace, I'm going out, okay? So the sender's address would be your phone number. The receiver's address, okay, would be the Carlos's phone, okay? Then there's an ID number, all right? And basically it's a position number. Because this envelope here could be broken down into, say, I don't know, 12 pieces. And each piece would have an ID number. Then there would be a position number, so it could be reassembled back together at the end, okay? So when you actually send a selfie, it doesn't go as a whole picture. It gets broken down into tiny little packets so that it can all be sent very fast through the network and then reassembled together at the end, okay? And an example that I've got here, quite an interesting example, oh, not yet, sorry, is the router, as I said, will first decide if the destination is in the local area network or outside of it, okay? So are you sending a message to someone that's in the same network? Okay, so like imagine if your phone was connected to the school's Wi-Fi and so was your friend, is it going inside the LAN? Okay, and if you are sending it within school, then yes, it would be. Then it'll get the address from a packet header, and if the destination is on a wide area network or on the internet, it uses an internal routing table and chooses the best route to take and the steps for the delivery. And then each packet will travel separately to the best available route and reassemble at the end, at the end. It's that simple, it's that easy. So here's an example. So a computer or your phone, you've taken your selfie, okay? And then here, it can go through the network and decide which route to take. So maybe several packets will go using route number 1, maybe several packets will use route number 2. Okay, so then that way there's a constant flow of data, there's no traffic jams, and the network can work efficiently. Now, what I've got for you is an example here, okay? So I thought this might be quite a good example for you to be able to get an idea in your head of how these packets are possibly sent. Now, the real London Bridge, okay, you've heard of London Bridge and it does exist, but there was another London Bridge, okay, and this was going across the River Thames here in London, okay. Now what happened was over 50 years ago, I think around in 1967, London Bridge was sold, okay, to Lake Havasu City in Arizona. So you think, well, how can they sell a whole bridge to America? But they did. They sold a whole bridge to this city in Arizona, okay? And the bridge was basically dismantled bit by bit, so brick by brick, and then it was sent to America, okay? And then it was put together, back together brick by brick. Well, how on earth did they do that, okay? Well, each brick, okay, was marked with a number so it could be put back together again. So as you can see, look, 2D37, and it was actually put back together again, believe it or not. So this is probably going in, I don't know, odd numbers, I don't know how they did it. But imagine that's something like, you know, when you send a selfie down WhatsApp, when you send a voice message, when you send a text message, whenever you send an email, okay, it all gets broken down so it could be transported, and each bit is given an ID and a position number so it can all be put back together again. Because obviously they can't just pull up this whole bridge and transport it to America. They can't just put an entire bridge like that on a plane. So it had to be dismantled brick by brick and put back together again, okay? Just like any data packet you send through a network. Okay, so a brief look at network devices, okay, but we're going to go more in detail in these next lesson. So the network devices simply connect computers to other devices together in one network. Okay, so once these are connected, they can communicate and share files. Okay, now there's always different file types. So you've got MP3, MP4, HTML files. Everything you see on a computer is no more than a file. Okay, when you listen to audio, for example, through Spotify, possibly an MP3 file. Why? Because the files are so small and they can store as many as they like. When you watch a video on YouTube, it's an MP4 file. Because when I upload my files to YouTube, I think they have to be MP4. Okay, so they accept MP4 files. Why? Because they're small. Because what they do, for example, with MP3 files, is a raw file of music will be massive. Okay, it's a huge file. So what they do is they reduce it by 90%. And then that 90%, so that file goes down to 10% of its size and it still sounds just as good. Why is that? Because they remove all the data that's not needed. So they remove all the metadata and they remove all the sounds that the human ear cannot hear. And the same with sites like Amazon. They're no more than a file on a computer, possibly HTML, okay? Right, so common network devices to set up a local area network are a hub or a switch. So in school we use all the computers are connected to a switch. Then that's connected to a router using cabling and Wi-Fi technology to send the microwaves around so we can pick up, you know, the laptops can pick up the signals. Obviously, network cards have to be in each device to be able to be networked. A modem, possibly, and this is what it would look like. Okay, but we go more into detail in this next lesson. Right, so what I'd like you to do now is I'd like you to complete this worksheet. Now, it's going to have to be downloaded onto Word, okay, or whatever equivalent you have. And to fill in the details, you can either right-click and edit text, or you can just simply draw in a text box. Please upload this as an assignment on Google Classrooms, and the best of luck to you.